Hello students, welcome to Shala.
Today we are going to do covalent bonding in hydrogen chloride molecule, water molecule and ammonia molecule.
But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel Shala. This gives us a lot of motivation to keep creating these kind of videos for you all.
Let us start with covalent bonding in hydrogen chloride molecule. Now hydrogen chloride molecule formula is, as you know it is HCl. Right children? Now first thing what we are going to do is we will write down the atomic numbers of hydrogen, that is 1. Electronic configuration is 1, that is K shell. For chlorine, it is atomic number 17, electronic configuration 287, KLM shell. Right children? So this is the first step you are going to do it. Now hydrogen contains 1 electron, right? While chlorine contains 7 electrons. That means we have to work on the valence shell, that is valence electrons in the valence shell. Correct children? Each atom requires 1 electron to acquire nearest noble gas configuration. Both atoms share 1 electron each to form hydrogen chloride molecule, which I am going to show you now. See. Now, first of all, this is hydrogen and this is chlorine. Right, children? Now, this hydrogen says, I will share my 1 electron. And this chlorine says, I will also share my 1 electron. So, out of 7 valence electrons, chlorine has shared its 1 electron. So, 7 minus 1, how many are left? That is 6. So, 1, 2, 3, 4, 5, 6. Correct, children? Now, this hydrogen says, now let me check whether I have attained my stable gas configuration, that is duplet. So, this hydrogen says, let me check. This chlorine will also say, let me check. So, checking wise, hydrogen comes to the conclusion that hydrogen says that I have attained the stable gas configuration of duplet, right? Chlorine says, let me check. 1, 2, 3, 4, 5, 6, 7, 8. Yes, it has also attained the stable gas configuration of octet. After completing this sharing part, comes the next and the final part is the bonding. Now, again I say that you have to remember those keywords that if you have 2 electrons or 1 pair, that means it is a single covalent bonding. So what you will do, you will show the bonding over here. So I write hydrogen because we have these 2 electrons, 1 pair. So it is a single bond and Cl. So this is the way we show the bond formation in hydrogen chloride molecule. So let us come to the next one. Now the next is the formation of water molecule. Right, children? So again the same thing. Hydrogen, atomic number 1, electronic configuration 1, K shell. Oxygen, atomic number 8, electronic configuration 2, 6, K, L shell. Right, children? Now, hydrogen contains 1 electron in its valence shell and it requires, that is only 1 electron to complete its duplet. Right, children? While oxygen contains 6 electrons in its valence shell here and it requires 2 electrons to complete its octet. Oxygen may complete its octet by sharing 1 electron pair with 2 hydrogen atoms, forming 2 single bonds. How it goes? Let me do it on the board now. Now the Formula of water is H2O. We know it very well. So this oxygen will come in middle and hydrogens will come on its sides. Okay. Hydrogen says, I'm sharing my one electron. This hydrogen says, I'm also sharing its one electron. Now, oxygen says, I have 6 electrons in my outermost shell. So what I will do, I will share one electron each with hydrogen atom. So this oxygen gives 1 electron over here, and this oxygen also gives 1 electron. And 4 are left over here. After this, the checking part starts. That is, this hydrogen says, let me check. This hydrogen says, let me check. This oxygen says, let me also check. So, the checking part starts. This hydrogen says, I have 2 electrons. I have attained my stable gas configuration of duplet. This hydrogen says, I have also have 2 electrons. I have also attained my stable gas configuration of duplet. This oxygen says, 1, 2, 3, 4, 5, 6, 7, 8. I have also attained the stable gas configuration of octet. Correct, children? This is done. The sharing part. Now comes the bond formation. That is the sharing of electrons. We have to see it. Okay. Now the sharing part, we check out over here that two electrons are here. So 2 electrons or 1 pair means single covalent bond. So what I will do? I will write it H. I will show single bond O, single bond H. This is the way we do it, bond formation. Yes, children? And we can also show these electrons over here outside. Right, children? So this is done. What? Formation of water molecule. Next, formation of ammonia molecule. What is the formula, children? Please tell me. 1 minute I'm giving. Hurry up. Yes, it is NH3. Correct, children? Okay. Now again the same thing. Nitrogen, atomic number 7, electronic configuration 2, 5, K shell. Hydrogen, atomic number 1, electronic configuration 1, K shell. We have to work on the valence electrons only. Okay. Hydrogen contains 1 electron in its valence shell over here, and it requires only 1 electron to complete its duplet. While nitrogen contains 5 electrons in its valence shell, and it requires how many electrons? 3 electrons to complete its octet. How it comes? Let us do it. Okay. Formula of ammonia is NH3. So what I will do? I will write nitrogen in the middle and 3 hydrogens on 3 sides. Correct. Okay. This hydrogen says, I am sharing 1 electron. This hydrogen says, sharing 1 electron. This hydrogen says, sharing 1 electron. Okay. Now, nitrogen says that I have 5 valence electrons in my outermost shell. So, what I will do, I will share one electron each with hydrogen atoms. Okay. Nitrogen gives its 1 electron. Nitrogen gave its 1 electron. Nitrogen gave its 1 electron. Out of 5 electrons, valence electrons, nitrogen has given its 3 electrons over here, means 1 electron each. So out of 5 minus 3, what is left? 2. So nitrogen says 2 over here left. Right, children? Now the checking part starts. Let us see. Okay. Hydrogen says, let me check. This hydrogen says, let me check. Okay. This hydrogen says, let me check. Now nitrogen says, let me also check. Okay. Nitrogen says, let me check. Okay, done. Now, hydrogen, 2 electrons, attain the stable gas configuration of duplet. Hydrogen, attain the stable gas configuration of duplet. Hydrogen, attain the stable gas configuration of duplet. Nitrogen's turn. Nitrogen says 1, 2, 3, 4, 5, 6, 7, 8. Attain the stable gas configuration of octet. Finished. They have attained the stable gas configuration totally. That is ammonia molecule. Now the last part comes as bond formation. Okay. Now let us check. Sharing part, 2 electrons, 2 electrons, 2 electrons. Okay. 2 electrons, 1 pair means single covalent bond. So what should I do? What should I do? I will write it over here. That is N. I will write it over here. N. Then single bond H. Single bond H and single bond H. Correct, children? And I can show also 2 electrons over here like this. As it is shown over here, I can show it like this also. Okay, so this is the bond formation of ammonia molecule. So this is the way we keep on doing the formation of covalent bonding. No matter it is single covalent bond, double covalent bond, triple covalent bond, having that keynote, that trick of remembering 2 electrons, 1 pair, single covalent bond. 4 electrons, 2 pairs, double covalent bond. 6 electrons, 3 pairs, triple covalent bond. So children, again I say keep on revising your work as your exams are very nearby. But do practice with pen and paper. Never do oral revision. So take care. God bless you. Keep on revising. Do well. Bye-bye. God bless.